see some basic concepts of time, speed, distance and work rate, and we'll do some basic questions. Let's start with time, speed, distance. So distance is equal to speed into time, or speed is equal to distance over time, or time is equal to distance over speed. That's the thing we use. And let's see one simple example. Let's say if I'm going from point 1 to point 2, okay, d is distance, so s is my speed, so time taken to cover the whole distance would be distance over speed. Now there could be a situation which says, so I increase the speed, let's say, okay, if the speed is increased, to cover the same distance lesser time would be required, okay. If the speed increases, time decreases. Let's say I double the speed, okay. So if I double the speed, I'll take half the time, okay. So for the same distance, if I'm traveling at double the speed, I'll take half the time. So speed is inversely proportional to time, okay. What it means is, so if speed is getting multiplied by 2, time will get divided by 2. That's what will happen. So if speed gets divided by 3, time will get multiplied by 3. That's what it means. Let's see some questions. So for every question, pause the video, solve it yourself, then see the explanation. So Janet must drive 90 miles. So if she drives 5 miles every 7 minutes. So for 5 miles, she is taking 7 minutes. Okay. So if I need to do 10 miles, 10 would be like 5 into 2. She'll take 14 minutes. 14 means 7 into 2. Now if I need to do 90 miles, 90 means 5 into 18. I'll take 7 into 18, 126 minutes. Okay. So that is the time I'll take. But if you see, the options are in hours. So 126 is 120 minutes plus 6 minutes, that is 2 hours plus 6 minutes. So that is our answer. So be careful about the units. There could be situations wherein in the question we have minutes or feet, and the answer options we have hours or kilometers or miles. So just be conscious about that thing. See the second question. Ahmed drives from his, let's say this is Ahmed's house, and this is friend's house. So while going to the friend's house, speed is 60 miles per hour. Okay, and the return trip means coming back to his home house from the friend's house. That means same distance, and the speed is 50 miles per hour. Now the total time taken for the entire journey, going to the friend's house and coming back, takes 11 hours. We need to find the distance. So instead of getting into some sort of equation, so we can do it by options. That's a better method. Let's say if we take 300 miles to be the distance, so the time taken would be distance over speed, 5 hours, and the time taken here would be distance over speed, 6 hours. 6 hours plus 5 hours, 11 hours. That's what it is. These are answer. Let's take another question. A motorbike leaves from point A. Let's say this is point A, leaves at 1 p.m. Let's say speed is SA. Okay. Then moves towards point B. Let's say this is point B. Okay. There's a car which leaves at 2 p.m. Okay. And speed is double, twice of SA. So in a lot of time, speed, distance questions, it's better to picturize the whole situation, okay? Make a pictorial representation of the whole situation on the paper. It'll help you understand what is happening practically. It'll help you visualize the situation. Now the thing is, the car at B started at 2 p.m. So when the car here started, A would have already moved for 1 hour, okay? And the motorbike started at 1 p.m. So at 2 p.m. he'll reach at some point. So in 1 hour, speed into time, he'll travel SA miles, these many miles. So at 2 p.m. the car also starts from this point, and they meet at 340. Okay, 340 means both of them traveled for 1 hour 40 miles. So 1 hour plus 140 minutes, 1 hour and 40 minutes. So 1 hour plus 40 minutes will convert minutes to hours. So that becomes 5 by 3 hours. So both of them traveled for 5 by 3 hours before the meet. So this motorbike would have traveled time into speed this much, and the car would have traveled time into speed. Speed is twice of SA, so 10 by 3 of the speed. That's what the car would travel. Now this point is 168 from point A, 168 kilometers from point A. So 168 can be divided into two parts. One is the SA part, this much distance. Second is this. So SA plus 5 by 3 SA is equal to 168. So it becomes 8 by 3 SA is equal to 168. So SA is 63 kilometers. That's what we get from here. Okay. So this part of the journey, this distance traveled by the car is 10 by 3 of SA, 10 by 3 into 63. That would be 210 kilometers. So 210 plus 168, that will be 378 kilometers. Total distance from A to B. That's our answer. Now there is another concept of relative speed. Relative speed is required, or this situation arises when there are two moving things. Okay, two things are moving. So speed of one thing relative to the other thing. That's what it is. So let's take a case when the things are moving in same direction. Okay. For example, a car is overtaking a bus. Okay. So let's say this is the bus moving at SB speed. This is the car moving at SC speed. So car is also moving in this direction, bus is also moving in this direction. Question is, how long will the car take? To catch, meet, overtake the bus. Okay, these three words, they mean the same thing: catch the bus, meet the bus, or overtake the bus. Okay, so we need to calculate T, how long, okay, how much time the car will take. So time, as we know, is distance over speed. Okay, distance in this case will be the gap between the two, initial gap between the two. The car is trying to fill that gap. So that gap, and the speed in this case that will take is relative speed. Okay, so gap, let's say D is the gap, okay, upon relative speed. So when things move in same direction, relative speed is difference of the speed. Okay, the bigger speed minus the smaller speed, SC minus SB. That's what it is. Okay, so we need to know the two things. One is the initial gap between the two things. Second, the difference of the speeds. That's all we need. Let's take a question. Timothy leaves home for school riding his bicycle at the rate of 9 miles per hour. Okay, 15 minutes after he leaves, that means, let's say Timothy, so in 15 minutes means 15 by 60, 1 over 4 hours. Timothy would have traveled speed into time 9 by 4 miles. Okay, so this is, let's say, home of Timothy, and he has traveled 9 over 4 miles. Okay, speed is 9 miles per hour of Timothy. Now, when he reaches this point, okay, after 15 minutes, his mother starts from the home. So this is mother at the home. Okay. Now the question is, if the mother drives at 36 miles per hour, so this is the speed of 36 miles per hour, how far in terms of miles must she drive before she reaches Timothy? Okay. So let's calculate how long she needs to, or for how long she needs to travel, how much time she'll take to meet Timothy. So this is the similar situation, things moving in same direction. Okay. So time taken to catch Timothy is what? Gap between the two upon relative speed. So gap is 9 over 4 miles. Okay. And the difference of speeds is 36 minus 9, which would be 27 miles. Okay. 36 minus 9, 27 is the gap. So she'll take 1 over 12 hours to catch Timothy. Okay. This is the time taken by mother to catch Timothy. The question is how long she needs to travel. So distance traveled by mother, speed into time. Speed is 36 miles per hour, time taken is 1/12, that is 3 miles. So she'll travel 3 miles before she catches Timothy. Okay, so if you're confused at any point, just go back to the question and watch the whole thing again. Now work rate. So work is equal to rate into time, the way distance was equal to speed into time. So in that sense, they are same. Okay, but the questions could be a little different. So let's go to the question itself. But basic formula remains: work is equal to rate into time. Let's see. Biff can shape 3 surfboards in 50 minutes. So 3 boards in 50 minutes. Okay. How many can he shape in 5 hours? 5 hours means 5 into 60, 300 minutes. For example, in 50 minutes he does 3. So if you take 100 minutes, 100 is 50 into 2, he'll do 3 into 2, 6. Okay. Now he is working for 300 minutes. 300 is 50 into 6. So he'll do 3 into 6, 18 boards. And that's your answer. Okay. Jim can assemble B crates in an hour. Robert can assemble 2 crates in an hour. So Jim, rate of working of Jim is B crates per hour, and Robert, the rate is 2B crates per hour. Working together at this rate. Working together means rate of Jim plus rate of Robert. Okay, the rates will get added, so they'll do 3B per hour. Okay, how many crates can they assemble in 4 hours? So in 1 hour they do 3B, in 4 hours they'll do 4 into 3B, 12B. Okay, that's our answer. Working alone, R can complete a certain kind of job in 9 hours. R and S, so in this case we take work as 1. Okay, so R can complete the job in 9 hours. Okay, so time taken by R is equal to 9. What will be rate of R? Rate is work. What work upon time? Work is 1, TR is time taken is 9 hours. So his rate is 9. So 1 over T means, because work is taken as 1, so 1 over T becomes R. And again, time taken would be what? Work upon rate. So 1 over rate in this case would be the time taken. So inverse of time is rate for us, and inverse of rate is time because we are taking work as 1. Okay. Same way, R plus S working together at the respective rates can complete one of these jobs in 6 hours. So R and S combined time is equal to 6 hours. So combined rate will be equal to work upon time 1 over 6. Okay. So rate of S plus rate of R. Combined rate is 1 over 6. Okay. Rate of R is 1 over 9. So rate of S would be combined rate minus rate of R. Okay. We just need to calculate this thing. So this will be 3 minus 2, 1 over 18. Okay. This is rate. Okay. Rate is equal to work upon time, or time is equal to work upon rate. That is 1 over R. So this guy S, rate is 1 over 18. So time taken for S would be inverse of that is 18 hours. Okay. When we are taking work as 1, inverse of rate would be time, inverse of time would be rate. So timing is given 9, so rate would be 1 over 9. Combined time is 6 hours, so combined rate is 1 over 6. So this combined rate 1 over 6, so rate of S would be this thing. So rate of S is 1 over 18, so time taken would be 18 hours. So we can do this question this way.